Okay, so this week we start to dive into project management as an element of operations management. And project management is a large concept to deal with in and of itself. It's typically taught in a separate course, but we teach components of it in operations management. One, because the elements of project management are often very similar or the same as the elements that we use in operations management. And two, because once we go through the process of decision analysis and operations management to decide what improvements need to be made, what investments need to be made, that often results in the beginning of a project to bring in those changes. And so that means that somebody has to either lead the project or oversee the project manager. Oftentimes organizations don't have designated project managers on staff, and they may not have the funding to hire a designated project manager. So typically that leads the project to be managed by the department manager. And as we know, operations centers in the organization to provide that day-to-day transformation. So usually those projects then fall to the operations manager. So it's important for us to understand some of these concepts so that we can, at the very least, effectively oversee the projects that are being done to benefit our department. So the difference between operations management and project management: operations is the day-to-day transformation of goods and resources into finished sellable products. We can, even if there's a customized order or a one-time specific order, does not necessarily mean that it is a project. That is the ongoing day-to-day business for that particular business. So maybe the business sells a custom product. So every single day they're building a new custom product to order. That would still be operations. Project management, and there are projectized organizations, is the one-time unique endeavor with a clear specific deadline and outcome and its own budget, resources assigned to it. There are projectized organizations such as wedding planners, construction companies, where every product they produce is a unique endeavor. The downside to projectized organizations means that if there is no product to produce, there is no home, so to speak, for the employees. There's no job to do. So that's one way to tell if it's a projectized organization or an organization that produces custom products. So what we're looking at is the data copied out from a sample problem from the homework assigned, and this is what we call a network diagram. And a network diagram shows the sequencing of activities to be done. So what this is showing is the task numbers are on top, and the days to complete are on bottom. And as you can see, the actual assigned time to complete or days to complete have an optimistic, most likely, and a pessimistic. And in other words, the best case, worst case, and the most likely. Our diagram shows our most likely, but we're going to calculate in our problem, we're going to calculate the actual average or our weighted average to come up with a realistic or realism schedule. But first we need to determine when these are going to be completed and what has to be completed first. So what this diagram is showing us is that 1, 2, and 3 can all start at the same time. But 4 can't start until after 1 is finished. And 5 can't start until after 1 is finished. 6 can't start till after 2. And 8, 9, and 7 cannot start until after 3 is complete. And what we'll also see here is that 8 actually can't start until 5, 6, and 3 are complete. So all 3 of these have to be done in order for 8 to start. And the project is finished when 11, 12, and 10 are complete, or when 10 and 12 are complete. So what we're looking for is the longest path, or the critical path, through the network diagram. And when we do this, we have to account for the longest time. So if we were to, 1, 2, and 3 can start at the same time. So their earliest start, and I'm going to put a couple columns in here for us, is going to be 0. Which means their earliest finish is the number of days that it takes to complete that activity. So 8, 10, and 9. And we're just going off of this diagram here. And then our next activity, so number 4, can't start until 1 is done. So the earliest finish for 1 is going to be 8. So if 4 starts on 8 when 1 is done, that means its earliest finish is going to be 12, because our 8 plus our 4 days here. Same thing for number 5. 5 can start when 1 is done. So again, on 8, it's going to take 6 days. So we are going to add 6 to our 8, 14. And then we would continue to do this process. And we would also work on our latest start. And our slack. Slack is the excess time to complete an activity before the next one has to start. So slack can be either latest finish minus earliest finish, or latest start minus earliest start. So let's finish working through our earliest start and earliest finish. On this one, our earliest start for number 6 is when 2 is done, and 2 takes 10 days. And that means number 6 will be done in 15. Our earliest start for 7 is when 3 is done, and 3 takes 9 days. So the earliest finish is 16. 8, as you recall, can't be done until 5, 6, and 3 are done, or can't start until 5, 6, and 3 are complete. So we need to look at the longest one that to get through this path. So we look at 3 is done in 9, 6 is done in 15, and 5 is done in 14. So the earliest the 8 can start is 15. And it takes 15 days, so 30. And then 9 requires 5, 6, and 3 also to be done. So we know that the longest path through there is 15. And oops, that one takes 12 days, so the earliest finish is 27. 10 can start when 4 is done. So we go all the way back up to 4, and it's going to finish at 12. And 10 takes 18 days, so 30. 12 or 11 can start after 9 and 7 are complete. So we look at 9 is going to be 27, and 7 is 16. So 11 can start at 27. And it's going to take 4 days, so 31. And then 13 or 12 can start when 8 and 11 are done. So 8 is done at 30 days, 11 is done at 31, and 12 takes 7 days to complete. So we're going to be at 38. So the longest path is going to be 38 days before we can finish, because 10 is done at 30, 11 at 31, and then 12 is done at 38. So if we start this at 38 and we work this backwards, then the latest that number 12 can start is going to be 31. 10 and 11 also need to finish by 38. So we're doing this exactly backwards, which means that 11 just needs to start by day 34. And 10 needs to start by day 20. So then we can go up to task number 4 if we're looking backwards from 10. Task number 4 then needs to finish by day 20, which means it needs to start, because it's 4 days long, by day 16. And if we're working backwards from 12, then 8 and 11 both need to finish by day 31. Did this one a little bit backwards. There we go. Correct that one. So 8 and 11 both need to finish by day 31. 11 is 4 days. We corrected that there. And now we're going to look at 8, which is 15 days. So it needs to start no later than day 16. So then we have 3 tasks here that either need to start or finish by the 16, or we also need to look at 9. So 11 needs to start by day 27, so 9 and 7 also need to finish by 27. And 9 is going to take 12 days and needs to finish by day 27, so it needs to start by day 15. And 7 needs to start by day 20. So 5, 6, and 7 feed into both 8 and 9. 8 needs to start by 16. 9 needs to start by 15. So the latest finish for 5, 6, and 3 has to be 15. And 6 is 5 days, so it needs to start by day 10. 5 is 6 days, so it needs to start by day 9. And 3 is 9 days, so it needs to start by day 6. So if 6 has to start by day 10, then 2 also has to be finished by day 10. And it's 10 days, so it needs to start on day 0. And 4 and 5, we need to take a look at for task number 1. 4 just needs to start by 16, but 5 needs to start by 9. So we use 9 for our latest finish, and it's 8 days. So we are going to set that at, it needs to start by day 1. So again, we can either use our finish formula or our start formula. So we can do latest finish minus earliest finish, or latest start minus earliest start to use slack. And I'm going to do latest finish minus earliest finish. And you'll see that our slack is 1 day. But you'll see that if we did the latest start minus earliest start, it's going to have the exact same number. So any activity that has 0 days of slack is considered our critical path. So, and this may come up if we're trying to estimate where the critical path is and if we could complete. So we started backwards from our absolute deadline. Our critical path may not be zeros. It's the lowest number. So in this case, it's all zeros. So this is going to be our critical path, and we would write it as 2, 6, 9, 11, 12. And what this tells us is that if, for example, we needed to borrow resources, if task number 2 looked like it was not going to be completed by day 10, that would ultimately push the entire project out. So if task number 2 went over to 11 days, that would push the entire project out to 39 weeks or 39 days. So if we needed to borrow resources, we could see that task number 3 can be done at the same time and has 6 extra days. Doesn't need to start until absolutely day number 6. We could actually borrow some resources there if that's possible. There's a number of other different project crashing techniques that we won't dive into completely, but this gives us an idea then of the longest path through the project. And this path can change. Certainly, even if a non-critical path activity were to go over or under, it could ultimately change the actual critical path mid-project. So it's important for us to watch the entire project, but with a highlighted focus on these critical path activities. So the next piece I'm going to show you is how to do this in POM QM. And you'll see I have the activity set up here. So this is under Module Project Management and File, New, and this is going to do a triple time estimate because we have our optimistic, most likely, and pessimistic. And so the next thing we want to do is set up our predecessors. So we're going to shrink this. And if you notice, you can set this up in Excel and copy and paste. So again, 1 does not have a predecessor, 2 and 3 do not have predecessors. 4 has a predecessor of 1. 5 has a predecessor of 1. 6 has a predecessor of 2. 7 has a predecessor of 3. 8 has a predecessor of 3, 5, and 6. They do need to be in numerical order. And 9 has a predecessor of 3, 5, and 6. 10 requires 4. 11 requires 7 and 9. And 12 requires 8. So the first thing I'm going to do is make sure and copy my task numbers and paste those into activities so that I'm referencing the correct references in our predecessors. Then I'm going to copy my predecessor list and paste that into POM. And we're going to hit solve. It's not liking how we have task 1 and 1 are different. So what this is saying is that this is a different name. Let's see if that takes it. Okay. We love it when technology, there we go. Okay, so this tells us then our earliest finish, latest start. It takes our activity time by weighting or averaging the most likely, optimistic, and pessimistic. It gives us our earliest start, early finish, latest finish, and our slack. So we have 2, 6, 8, and 12 based off of our average activity time. It also gives us our standard deviation, which is kind of our give and take for activity time. And now we want to look at our windows, and we can actually look at our chart. And this is another, this is a Gantt version of our critical path or our network diagram. And we see that the tasks in red relate to our critical path. So again, this can be either done in print screen or saved to Excel file if you need it for your homework. But I hope that this gives you a good idea how to complete in both POM QM and in Excel.